The next property of an antenna that I want to characterize is what's called input impedance. And in the figure here we see that I've got some sort of antenna, and it is connected to a source at its input terminals. And here I've marked the input terminals, the antenna A and B. And we've got some sort of, as we know now, some sort of radiated wave that leaves the antenna. The input impedance of the antenna is the total impedance that the generator is going to see once the antenna is connected to it, and we call that Z antenna, input impedance in the antenna, and it in general consists of two parts, R antenna plus JX antenna, just meaning that an antenna input impedance has a real portion and a reactive portion. So ZA is the antenna input impedance, RA or RA antenna is the antenna resistance, and X antenna is the antenna's reactance. For most antenna, this will be approximately equal to 0, so we typically don't have to worry about this. And instead, we're more concerned with the resistive portion of it, which consists of two parts. So the resistive portion of the antenna consists of two parts, one which is called the dissipative resistance, and one which is called the radiation resistance. Sometimes this is called the loss resistance, and sometimes this is called, is just shortened to RR. So you'll see different symbols used for those. So RR or RRAD is the radiation resistance of the antenna, and RDIS or RL is the loss resistance of the antenna. So of the power that's delivered to an antenna from a generator, part of it is going to be radiated through the mechanisms of radiation that we've discussed earlier, and another part of it is going to be dissipated as heat, decreasing the overall efficiency of the antenna. And so that's where the efficiency calculations come from, is basically, well, what is the ratio of RRAD to total antenna resistance. Sometimes we'll talk about lossless antennas where RL or RDIS is 0, and that just means that we've got some sort of lossless antenna in which all input power is delivered to radiation. In these cases, assuming that the antenna is matched to the generator, we get best case radiation. Half the power is radiated by the antenna here, and half of it is generated or is dissipated in heat in the generator here due to the maximum power transfer. So if we've got, I'm just showing here, if we've got an antenna, we can replace the dipole antenna here with its equivalent input impedance, which is just equal to RDIS RRAD JX antenna. So this radiation resistance of an antenna is going to depend on many factors. This RRAD, it's going to include the geometry of the antenna. It's going to include the method that the antenna is excited by, whether it's a sinusoid or a pulse function. And interestingly, it's also going to include proximity of the antenna to surrounding objects. So if this antenna is close to a metal surface, its radiation resistance is going to be different than if it's far away. So when we're measuring radiation resistance, we really need to put the antenna high up away from any sort of structures if we want to get a good measurement of what this is. And most often radiation resistance of antennas are measured values. There are a couple exceptions to that, but by and large they're measured. So let's see, is there anything else I want to say about antenna impedance? I think that's it. So I got a couple models down here where I have shown you how to analyze either a transmitting antenna or a receiving antenna using the different antenna input impedance circuit models right here, and I've also included those for the generator. So if you have any mathematical calculations that you have to do using antenna power consumption or efficiencies, you can use these two models to do those.